All right, in this exercise, we're being asked to integrate x squared divided by the square root of 1 minus x. Now, this one is going to be kind of a tough one because when you go through your normal integration techniques, nothing really seems to work that well. First thing a student would likely think is, okay, here's a fraction, maybe it's the log rule. Well, it's pretty clear that x squared is not the derivative of square root of 1 minus x. So you don't have that integral of du over u type format that log rule would require. Next thing a student might think is maybe because of this composition, the square root with the outside and the inside, maybe it's u-Substitution. So at first glance, you would typically let the inside be the u, so you'd have 1 minus x, and then a student might be tempted to dismiss this because du would be negative 1 dx. That's the derivative of this u expression here. And they would likely see this x squared and think, okay, well, what in the world are we supposed to do with this guy? Well, it turns out that this actually is the right approach. We just have to be a little careful how we proceed. So we're going to leave this as our choices. I'll write them on the next slide. Here we go. All right, and based off of this choice for u and du, we can start to rewrite the integral. So that integral that was from up above, we'd have the integral of, let's see what we would have here. All right, clearly the bottom here would be the integral with a square root of u in the denominator. That looks really nice. This du, if we had minus 1 dx, we could swap that with a du. So currently I've got a dx, so if you added in a negative 1 on the inside and the outside, as we often have to do, then I can change out the negative 1 dx for du. That looks pretty good. I still have this negative 1 on the outside, but then here comes the hiccup. Here comes the probably most difficult part of this exercise. What do we do with this x squared? Well, here's something we have to do every so often. Not all the time, but every so often. If you have another expression in terms of x that doesn't immediately fit u, you can take this guy right here and solve him for x to see what x is in terms of u. Normally we don't have to do much more than this. But if you notice, if you solve for x, let's say if you added x to the left-hand side and subtracted u to the right-hand side, not only is u equal to 1 minus x, but if you rearrange the terms, x is the same as 1 minus u. So when you have x squared, we can swap that with 1 minus u squared. Now, at first glance, you look at this and you say, well, Devin, that's not much better than what you started with. That looks just about as ugly. Well, there's one key part to this that does make it a lot better, and it's the square root expression. Rather than having the square root of multiple terms added and subtracted where you can't break apart the square root, we just have the square root of a single expression, and I can already see the finish line. We can FOIL the numerator, and then because this is a monomial, just a single term, we can break it up into 3, 4, 5 different fractions, however many we need. So let's proceed here. This will be minus 1. The integral of FOIL the top, 1 minus 2u plus u squared divided by u to the 1/2. That's square root of u. Then we have minus 1. And we're going to take this guy and break it apart into 1, 2, 3 separate fractions apart over this minus and plus right here. So 1 over u to the 1/2 would be u to the minus 1/2. And then you'd have minus 2 u to the first divided by u to the 1/2 would be u to the 1/2. What I did there was subtract exponents. U to the 1 divided by u to the 1/2 would be u to the 1 minus 1/2. You subtract exponents when you divide. And then plus u to the second over u to the half would be u to the 3/2 du. And now we're on the downhill slope. That's pretty integrable right there. We'll have a minus, and then we'll integrate each of these. Add 1 to this exponent, you'd get u to the positive 1/2 divided by 1/2. But as we typically do, rather than divide by a fraction, we'll multiply by 2 over 1, which is just 2. All right, and then minus. All right, this will be 2 times, and then we'd have u to the 3 halves with a 2/3 out front. And then lastly, u to the 5 halves with a 2/5 out front with a plus c. So final answer, I'm going to do 2 steps in one if you don't mind. I'm going to distribute this negative. So we have minus 2, u to the 1/2, so that turns back into a square root. And rather than writing u, I'm going to go find out what u was. Here it is, it's right here. U was the same as 1 minus x. So I'm also going to get that u out of there and swap it with a 1 minus x. All right, minus 4/3, that's 2 times 2/3. 1 minus x to the 3 halves, that's u to the 3 halves. And actually I need to change this minus to a plus right here. I just noticed we have to distribute that negative to all 3 terms. So it'll be a plus. And then minus 2/5, 1 minus x to the 5 halves plus c. So this will be our final answer here. So it's just a little tricky just because you had to use this extra not very commonly used technique of not only doing u-substitution but solving for x in terms of u for other random terms that have x in the expression. So it's just something we have to do every now and then. I just wanted to show you an example to expose you to that concept. But once we did that, it was pretty straightforward.